Okay, so now on to video number 2. We're going to do some of our practice for classwork 2. And once I get on the video, you're just going to go ahead and work on it with a partner and, get your practice in. All right, so let's get to it. First and foremost, we start with Boyle's Law. Boyle's Law is this nice little formula here. Remember, this is inversely proportional. As one goes up, one goes down. So the first thing you got to do with any one of these laws is identify all the parts and pieces. So first thing I'm going to look for is, what are my pressures? I got pressure here and pressure there. And that's way too big. Let me shrink that down a little better. So pressure here, pressure there. So that's going to be on my P's, is going to be my other P. We also have volume here, right? So we got volume here and asking for a new volume there, right? So that's what we're trying to figure out. Now, what is what? We got to figure out when we look at it. So when you read it, it says the volume of a gas is 99.0 kilopascals at 300 milliliters. Guess what? That's how it started. So that means that this is P1 and that's P2. And that makes this one V1 and that V2. And I'm looking for V2. That's what I'm trying to find. All right, so now that I've identified all my stuff, I'm gonna plug it into the formula. So we just take P1, which is that 99.0, and we multiply it with our V1, which is 300. All right, and then we're gonna take that answer and we're gonna divide by what's left over, because we gotta isolate V2 by itself, and so you divide both sides by P2, right? So P2 is 188, and if we do all that, we get 15797872 blah blah blah. And siggy figgies, I got 3 sig figs here, 4 there, 3 there, so 3 it is. That 9 can change the 7, and I get 158. Hey, this is volume, so I just give milliliters, so it stays milliliters. It's what I put in, it's what I get out. Now, usually you want to see what substance it is, but it just says gas, so guess what? That's good. So the rest of these Boyle Law questions are kind of just like that. You're just trying to figure out what's what. For example, you go down here and go, hey, look, there's pressure. There's volume and volume, right? So you're kind of figuring out what's going on. Number 3 might get you a little bit, because you'd be like, hey, I found pressure, but then I got increasing pressure by 25%. That's weird. And it's got volume, and it's asking for the new volume. So you also got to figure out, what is this by 25% thing? So let me kind of look at it this way, right? If you have pressure, right? So let's say this is my P1, right? So let's say I've got P1. Well, if I multiply it by 0.25, right, that's going to equal 25%, right? So if you multiply it by 0.25, that number, and then because it's increasing, right? If it's increasing, we're going to add it. Actually, probably the other way. We're going to add to our original P1, right? That number times 0.25, and that will equal our number that we're trying to find that goes right here, okay? And that will be our P2. So really, this equals P2. So P1 plus this inside parentheses, that times that, plus P1 equals P2, okay? So there we go. We got that going. All right. So, and that's it then. So that's pretty much your Boyle's Law questions. Then we got our Charles Law questions. So now we're looking at volume and temperature. So our balloon over here is our initial states. So here we've got our V1, and here we've got our T1, right? Right, here we go. So here we go. This is my T2, which means that it's asking for a new volume. So hey, that's my V2. All right. Here's the thing, guys. You're looking for this. Now remember, whenever you've got 2 fractions equaling each other, a little trick of the trade is to multiply the diagonal, right? So multiply the diagonal and then divide by what's left over, okay? So what does that even look like, huh? Well, let's plug our stuff in and I'll show you what I'm talking about. So we got V1, which is divided by 350. It's already in Kelvin. How nice is that? And then we're trying to find our V2, and that's being divided by 250. Now, if this was in Celsius, that's, you'd have to change it to Kelvin. But right now it's Kelvin, so we're good. Now you have other ones down below. It says it's given to you in, say right here, this is given to you in Celsius. Well, you better add 273.15 to it. You're going to get an answer in Kelvin, but it wants the Celsius temperature. So that at the very end, when you're done, after you find your answer in Kelvin, you're going to have to subtract 273.15, okay? So don't forget that. All right, that's number one. I'm not going to do that for you. You're going to figure that out. Now that cross multiply divide thing I told you about, you're going to basically multiply those two numbers and divide it by that one, and it looks like this, right? So I'm basically doing 4.3 times 250, and I'm dividing my answer by 350. And if I do that correctly, right, it's going to be 3.071425 and some noise. So right, Siggy Figgies, we got 2, 3, and 3. Actually, they don't look like they're really 3, and they look like they're 2 and 2, huh? Well, 2 anyway is what we got. So the 7 can change the 0, so it becomes 3.1. And because we're talking about volume here, and it's given to us in liters, it's liters. Does it say what kind of gas? Nope, it just says gas. Okay, so look out for if it actually tells you what the substance is. All right, so that's a Charles' Law problem. Remember, you're just like cross-multiplying the diagonal and dividing by what's left over. So if I was solving for V2 here, right? I was solving V2, so I had to multiply these guys and divide by this. Well, if I'm trying to solve for that one, right, then I would multiply these two and then divide by that. So it's just the same kind of idea. It's just the whole idea of proportions. It's an algebra trick. Okay, so these are all very similar. This one's got to reduce the volume by 45%. So that means, just if you're trying to figure this out, right, my V2 is going to equal my V1 minus V1 times 0.45. Okay, so just be aware, this right here, that's that. And this right here is my V1. We got my T1. It's trying to find the new temperature. That's my T2. I should have bolded that one. I'm sorry there, guys. All right, so that's your Charles' Law. All right, so Gay-Lussac's Law. Gay-Lussac's Law, a lot like that one, remember? Same idea. If I'm missing this guy here, I would multiply these two and divide by that. So just kind of keep that in mind. So let's see what we got here. So we got some pressure stuff. So we got 1.5 atmosphere. And what will the pressure be? We've got temperature here. We got temperature here. Do not worry about the volume of the container. The container, it's a rigid container, right? That's what Gay-Lussac's laws are. All right. So the thing about temperatures, remember, we've got to add 273.15 to both of these. All right, so they're both getting 273.15, and yeah, that's all we need to know. So we're pretty good. All right, let's plug everything in. So we got two fractions equaling each other. I got P1s on top, so I got 1.50. I do not know my secondary pressure. I do have some Celsius changes to make. So at basically, remember, just let me stress this out here. P1, P2. Keep the color going. This is T1 and this is T2 there. Okay, so T1 is 20 plus 273, and you should know, oh, that's 293. Okay, so P2 is going to be 50 plus 273. Well, that's going to be 323.15. Okay. So we got stuff in Kelvin, so we can go forward. Again, it's that whole cross multiply and divide by what's left over. So if we do that, right, it's going to be, so there we are, it's going to be 1.653505. And Siggy Figgies, we've got 3 here, 3 there, 3 there. Hey, look at that, 3 it is. All right. So the answer becomes 1.65. Now, the thing is, this is pressure. It was in atmospheres in the beginning. It's in atmospheres in the end. Does it say what kind of gas? Nope, just says gas. And we're done. All right, there's your Gay-Lussac's problem kind. Now, anything crazy going on here? You have the pressure to double. Well, this is my pressure here. Obviously, it's that number times 2. So come on, y'all. You can figure that out. This is asking for Celsius. And guys, you might get negative Celsius somewhere. It's okay. You can have negative Celsius because remember, 0 is when water freezes. There's below freezing in water, right? So there can be all the way up to negative 273 Celsius. But if there's any more than that, really, you kind of did something wrong. Okay, just remember that. All right, so that's Gay-Lussac's law. So take a minute, look at that, get it written down, and then work with your friend to get those figured out. So last example, combined gas law. Combined gas law might be a little bit of an iffy thing. Let's see here. All right, let's see how you guys do. All righty. So cool thing is our little picture here has all the initial states, so that's pretty lovely. So here we've got our T1, we got our P1, and we got our V1. Okay, remember that T1, I've got to add 273.15 to that sucker. All right, hey, look up here, it increases to that. So guess what? That is T2. And don't forget to add 273.15 to that sucker to change it to Kelvin. All right, got pressure here, and the pressure increases. Let's see, find the missing. All right, got our stuff here. So basically, this 1.2 here, that's going to be P2. And this is going to be like, it's supposed to move up and down. We're going to have to find V2 to find out that answer. So you're going to find V2 and be like, does my volume shrink or does it get bigger? And we'll go through that. So this is a little bit more cumbersome to plug in. So you got to kind of work it one little bit at a time. So P1 times V1 is going to be 1.00 times 30.0. And then all that gets divided by T1, which is 273.15 because it's 0. All right, and then it's going to equal. Now, we do not know what P2 is, so it's going to be, we do know what P2 is. We don't know what V2 is. So it's going to be 1.20 times V2, and then all that gets divided by 30 plus 273, which is 303.15. Now, you can't really cross multiply and divide that easily because this guy is not one number, it's two numbers that are together. So you're gonna have to kind of do it in chunks, all right? My advice to you is to take your time with it. Don't rush the thing because people rush it and then they go, I'm befuddled. So do like this multiplication first, then take that answer and then divide it by this. Get an answer. Then see this over here is being divided. Well, then take your total answer you got over here, right? On the left side, take this total answer and multiply by that number. Hey, now that's gone. All this is now a number. Now all I've got left is just these two being multiplied. And what's the opposite of multiplication is division. So divide by that. So multiply this, divide that answer by this, multiply that answer by this, and divide that answer by this. And guess what you're going to get? You're going to get an answer. Go figure, right? It's going to be 27.745744, and that's it. Siggy figgies. Oh, we got 3, right? 3. So that's it. 3. So first 3, 4 can't change to 7, so it becomes 27.7. It's volume. So that's going to be in milliliters. Now that's not our final answer. The question here, because this is V2, the question here is, does the piston go up and down? Well, if it originally was 30, now it's 27.7, it shrank. So my piston went down. So the answer here is the piston went down, okay? But that's what your V2 ends up. So because of that, you can find out the piston went down. All right, so that is a combined gas law problem. You got 3 of those to figure out. Biggest thing is make sure your temperatures are converted to Kelvin before you plug them in the equation. If it asks for Celsius and answer, you will have to convert back to Celsius from Kelvin. But other than that, it's pretty straightforward. These aren't too bad. Work with each other, get them figured out. You've got examples. That's all you really need. That's all we need sometimes. All right, I hope this helps. And that's it for the video.